So, ladies and gentlemen, Mastringer is here, and today we are going to be working on the STM32. First of all, adding the temperature sensor, which is a MAX6675. Then going to move on to adding the code into the STM cube. I've already set the pins in the MX. Then we're going to test it with a heat gun, and then going to move on to a bit of cleanup, because as you probably have been able to see on the thumbnail, it is a cluster of fog, I would say. Maybe I shouldn't have said that, whatever. So it's a big junk, not junk, but you know, it's a spaghetti of wires right now. So I would like to clean the whole thing up, as well as I have some extra lovely things here that I have not been able to just yet do. So we have the, just wait a minute. So we have this thing here called the what is this? The stepper motor that drives the needle valve. Basically, this is a needle valve that adjusts the compressor air into the oil gun, the burner's oil gun, which basically this is for the oil gun, so that it sprays the oil or diesel, whatever we want to ignite, into the fire clean, that we can ignite it. Because if you just pump the fuel into the fire, it's nothing is going to happen other than just quenching the fire or just fucking the whole thing up. But if you spray it, meaning that you break it up into very fine droplets, then it will be able to ignite one easier. And I mean, if you pump the fuel into a very high flame, it will ignite, but it will not burn completely thoroughly. Maybe on the outside, because if you imagine like a bubble, then on the outside it will burn, but nothing more, and the inside will remain unburned, and it will evaporate into a vapor, I would say, that will go out with the exhaust. So we don't want that, because that's wasteful. So therefore we have the atomization, which is basically just meaning that, fancy word, to break up the fuel into very fine droplets, and that can be ignited. And this is what it does. Or I mean, this allows the air into the oil gun. And besides, back to the point that I have printed out new legs to it, and we'll work with that as well. So currently, I mean, I have broke the thread, but the main point of this is that we have this carriage that we want to remake as well. We have this thread here that basically sits onto the top of the needle valve, as well as into the other part is set onto this stepper motor, and the stepper motor controls it from the STM32 board. The stepper drives the needle, or the needle, as well as this screw here in two pieces. This is like a trapezoid, I think, whatever, it doesn't matter what type of screw it is. It drives the carriage with it up and down, and that will move this linear sliding potmeter that will signal us the position of the needle. Because I just started out with a little limit switch here that acts as kind of like this. Basically, that's the whole thing, home and then go back, and then we know where we are. But the problem is, even when you move the whole thing up a bit, and then you stop, and then you start to move it again, there is a thing called stick slip, which basically does that. You apply force to it, it doesn't move yet, but at a certain degree it starts to jump, and that basically you already moved the needle, because there is a bit of like wiggly woggly between the screw and the carriage itself. So you already have moved, let's say, a quarter turn, but this thing didn't move just yet. So that gives us some room for error, and these errors overlap and they add together when you move it a lot. And every time you add some error, there is a, I mean, I wouldn't say possibility, there is always error. So they add up, and that creates a distance, or like a difference from, let's say, we have the position of 6000, but in reality the position isn't 6000, it is like 7000, or in reality it is lower because we move the needle more than the carriage moves. So let's say that in reality it is only 5000 instead of 6000 that he basically the STM32, so to speak, knows, because he sets the needle and there is no feedback. So that is why we need this thing. We will put it onto the carriage somehow. I will still have to think about it, how to do it. But when that is done, then we will be able to run the carriage and know exactly where it is, because the potmeter will send us an analog value that we are going to analyze with the STM32. I'm going to put this there. So yeah, I have a lot to do today, so I won't even waste time anymore. This was the intro. Let's jump right into it, shall we? So open the chat window. All right. If I can put it here somewhere. Here. I think this will do. So yeah, let's jump right into hooking the whole thing up. So what we need is this. Yeah, not this one, the other one. This. Oh, I really hope I muted the. Alright, okay. Because I'm playing some music. I'm gonna stop it now. Do not need it anymore. So I don't think this is it. Oh fuck, maybe which one is it? Hello. Wait a minute, I will need to find my thing. There is all. Oh, fuck. Which did I write it into this? Maybe this. Yeah, this one. So I don't know why. So these are the current pins that we are going to use. Already set them. These are these pins. So we have the PB1314 and I believe the 12, which I can't see. Where are you? PB12. Huh? Why the fuck is it so far away? Why not 15? Ah, PB12 is out of the fucking. Totally logical that you put the PB12 up here, right? Whatever. So PB14, 13, 14 and 15. Okay, so going upward, not this one. We put it to not Moshi, GPIO output. This will be reset state. This will be set to, or not here. T1, so this is the temperature. Fuck off. Temperature 1 CS or J. This is basically here to, I mean, if you don't know about it, these pins are the CS is that's the clock, MISO is, I think it is internal I don't know which one. The SCK is definitely the clock. I don't know what the MISO does, but the Ch is CS is basically signals back, reads the data. I might be wrong completely that the MISO does that. Whatever. So we need all 3 pins so that we can connect to the MAX6675 so that we can read the temperature sensor. First of all, I will open this, make myself bigger. Why is this? Oh, fuck me. This is... What the fuck is this? Oh, wait a minute. I need to stop this. Oh, no. Don't care. Sorry. Settings. Fuck off. Come on. Sorry, just have to figure this around so that... Why is this little... I don't know why it is like this. Settings. Annoying as fuck. What is this fucking frame size, man? Who said this? Who the fuck said this? Yes, I don't care. Over end screen. Where the fuck is this? Anyways. Maybe I will put this here so at least I can see the chat. This is annoying as fuck. And yeah, well, I'm not going to fuck. I don't know why this does this, whatever. So besides that, we so we have this lovely thing here. Oopsie. Can I zoom? Actually, yes I can. Oh, fuck off. Okay. So what we do have here is the board. As you can see, I have taken it off so that I will be able to replace this piece with the proto board later on. But first we will work with this thing, which is the MAX6675, which is the thermocouple board. Here we have the thermocouple leads, and yeah, these are the pins. These are the 3 pins that we have just configured. These 3, the white, the orange, and the yellow, and we'll need to connect them to the appropriate pins. So we'll need to hook up the power, the VCC, as well as the VCC as well as the ground, so that we have connection. This is not too tight. Whatever. Am I going to put this here? Only problem is I don't have the dumbass whatever. So we need the purple and the brown for now. We'll put the brown here. So it's 1, 2, 3, 4. And this is the ground. This is the 3.3 volts. need to stick this here with a piece of glue, but I don't have the glue gun here. So, going to stick the glue. Going to. If you have any questions, feel free to place them in the comment section or into the chat. I will now just a quick second plug in the hot glue gun so that we do start to melt the hot glue, and we stick it in here as well as this. Yeah, as well as this, so that the board doesn't move, because it is very annoying because the ground pin wants to jump off. Yeah. For now, we have these 3 pins here that I will need to figure out which is which. See, so the yellow is this SO, which is the meso. HCK is white and Che is orange. So 14, 15 and 13. I will need to find which one is which. AGND. So this is the 4th, 5th is the PB13. Okay, at least this is now in nice order. So 1, 2, 3, 4, 5. The 4th is what we want, and that is the HCK. The 5th is what we want from the bottom of the side row. Oh. Yes, the problem is that we must not use these. Oh, fuck me. We need to use the females, not the males. Alright, fine. Do we have... yeah, it looks good. Orange is replaced. Need to replace the yellow as well. So, yellow to something different. White is not an option, because there is a lot of whites, but this is white. There is white and grey as well. Maybe there was grey. Hope the hot glue gun has already reached them. Okay, it has. So what I will do now is that come back. Does it really? I mean, I don't even have to. Much this powerless. So here's the power, because it stays hot. Can glue this here. Right, it has already solidified, which is lovely. I think it did. Right, we can replace the... I'm pretty certain that I have a lot of these little dumbass Yes. Okay. Hot glue gun, back to your place. Thank you for your service. Okay. We have the little pins here. Sit down. Okay. Always the wrong side, man. Okay. One is wood. Here comes the second. Hope this will fit. Might have. Which one was it? The white. I mean, I can pull all of them off so that we can put the. Yes, this can be used. So the white and this one and the orange one. This is going to be the miso or the mosaic miso, yes. Okay. Well, how is this? Where the fuck is my screwdriver? This fucking shit. Whatever. Alright. Put the other one as well. Put this on. Okay. Here we have this. Now what we need is to figure out which one is which. Again, I have to look at the chart. So the CSK or clock CSK is the CSK, so this one, which is the white one, that's the first. The S shape, that's the third one. So actually the miso, which is, yeah, so it should be white. White should be the fifth pin from the bottom. I don't know, should we put it over? I'm probably on there. So 1, 2, 3, 4, 5. If I can count, yes, that is 4. Will you go down or is it? No. It needs to go down further. Alright. Orange. And then the off-white. I should have glued this as well. I hope that no one has wandered off. Alright. Would like to put this somewhere here. I think I will glue the morpho pins down. Here have some leftover room so that we can connect the board. Alright, plug the old glue gun as well. Again. Still hot. Cooled off. So I really hope this is alright. 13 is the HCK. Mizo and Che is the last one. So this fucking shit. Alright. So we have another board here which is called the MAX6375 or whatever. And this is it. We have this big fat ass thermocouple. Yeah, connected to this. So this is kind of like a makeshift one, but the main point is that this is all ceramic. So then basically it can be, it's K-type thermocouple, can withstand like 1300 degrees or whatever. So it is pretty good. Yes, this MAX6875 didn't work back in the day when I was trying it out. I want to figure it out why now. Hopefully I am a bit smarter and more capable of solving the problem, or can figure out something. We have to see. Alright, put this back in that place. I think the hot glue has already started dripping. Great. Now we will put the pins, glue down the pins a bit so that it is a bit more stable. At least on both sides. Fuck off. Do it from here now. Peel off these morpho pins. Big grey stuff. First when I was getting used to it, it was a bit more annoying, but I realized that, or learned that if you have the male pins, these are so much easier to connect the male pins with, because if you have like female to female connectors, those are so much better than these little shitty Arduino female pins, because the male pin just wants to wiggle out, and the first movement that you apply to it will just make it jump out of the fucking connector rather than off. Yeah, sure, the females can get off as well if you crimp them a bit, meaning that you take like a plier, press onto them a bit, then they get more tight, and then you press them onto the male pins, and then they are wonderful. So The main question is, will this open? What is stopping us? Oh, the thing. Yeah, now I didn't glue it onto the side, which was last time and a bit problematic. Yeah, and if I'm correct, these are kind of stable right now, so we don't wanna jump out, jump off on this bullshit. So, and alright, lovely. So we have connected the board itself. We need to configure it in the MX, and then I might get to disassembling this shit and these little motor controllers as well, because I am very pissed off with them. They take up a lot of space for no reason. So the plan is that I will need to think. I mean, you'll need to think that I might have tried this board, this MAX6675, because one of the pins got, basically the middle pin got low air, because I have applied too much heat to it and basically dipped into the plastic, so it melted through it a bit. Yeah, not the best. Besides, we need to get this off soon, not now. We need to get the little boxy I have here, which has full of good stuff. But the most important thing is to us is this, which are female pins, as well as this, which is a board that fits right exactly here. Lovely. Well, these proto boards basically are better than these little shitty ones, because they have internally linked or under linked, and actually two, so we can use one for 5 volts and one for 3.3 volts. Lovely. And have 2 grounds, so I really like it. Oopsie doopsie. I will put this here. Alright. So for now, we'll go back onto the PC and then go back onto the PC and then add the code so that we can read this shit, and also find the temperature probe. Thank God I have brought this in. So we have this temperature probe. It is a bit beaten up, worn out. Already I did some tube to it and all that bullshit. So he's not the loveliest, but I would say he is probably seen a lot of stuff. So plug him to the socket if I can. Yes. Alright, we have a temperature sensor added. So we have the end here. We'll double check. So the SCK is the 5th pin from the bottom, which is SCK 15, or like So this 13 is the bottom fifth, 1, 2, 3, 4, 5, 13, yes, this is the SCK. SCK, MISO is 14, which is the next pin, which is this, MISO, that's fine. And 15 is this J or CS, which is the communication pin. And if I'm correct, so SCK is the last 13, J, which is the this is a SO, and the CS is the middle one, yes, which is the offline. Alright, that's great. So then we are rice and nice. We'll need to check if the pins are connected properly, because this bitch just wanted to jump off. Okay. Purple is the 3.3 watts, right? So way in, ground. So one ground is unused, great. I mean, I could use the ground from here, or yeah, I could have used the ground from there. Whatever. So this is the fourth one, right? 1, 2, 3, 4. Okay. Okay. Yes, ground. This is 5 volts, 3.3 watts. Okay. So we are fine. Don't want to fry the board. You cannot use the 5 volts, only the 3.3 volts, because and the thing puts out the VS, so the source voltage, minus 0.4 at the CS, so we don't want to fry the 15th pin, or yeah, 15th pin already. So now we'll jump to the whatever this is. So let's see. All right. Yes. On the user config main H. Yeah, we can share SCK and MISO, so we can cramp the use the little rails or logos that I have. Later on I will be able to use the oopsie, the what do we call them, the god damn it, the protoboard. To it, for now we can use this crimped. We have these. I will show. These are this. Had this long. There is like this rail that focus. Oh, no way. Come on. What up? Hello. It is like, sorry. So this shit doesn't have focus. What a fucking shit. So there are these rails. I'm gonna pull it out. So basically, if I tighten them, they have this. You can see that this is like a yellow, like a I think it is made of brass, and they are here. I've cut these, so this is like a rail, brass rail that you can use with these screws to hold the things, kind of like valves, but they are, so to speak, they were here, and I have cut them up so that they can be reused rather than just wasting around, laying around and not utilized. So yeah, unscrew these. So I will try the other thing as well. For now, one CS shit is enough, or one what do we call this? One connector is enough. I only have one thermocouple here. So yeah, MAX. I will ask the where is this ID? Maybe we should integrate a new code just to test it out, because this is very big currently. Whatever, we have to do it anyways. I'm going to put it. I think I have it in the. Sorry, I just need to find the file where it is. Burner. I think it is the compressor air screw, and yes, it is here. Stepper V16, I think it was this. Yes, we're going to create a new one. V17. Alright. W. So we have this big set of thing. Mod. So yeah, going to upload this. Of course not. What do you call this terminal? Going to open the MATLAB terminal. So yeah, I need to redo this. This is ugly as fuck. The space here. This is the what do you call this? The stepper control that is here. Chopper. Bus rails. This is the 12 volt, not 24. This is like ground. G and D. So yeah, well, maybe use this thing here. This is the ESP32 Wemos, kind of like the Uno, just with ESP chip. We'll be able to communicate with this. We don't even need a level shifter, so that we can basically command him from online rather than with the serial thing. We just need to plug him into the connector, into the power supply. Thank God the power supply has two USB cables, so we can basically take one USB and plug one in here, plug one in here. This is micro, this is micro B, and this can communicate with him and command him the things from the MATLAB that I send the things online as commands. That is kind of like a future update, not now. So yeah, shit is standing up, standing by. Mm-hmm. Mm-hmm, mm-hmm, mm-hmm. We don't need this. We need the... I think this is the MATLAB file. Yes, and what is the STM32 shit? Boof. This is still MATLAB. Yes. Yes. MATLAB will can wait. Map on. This is actually very cool. Didn't think about this. Yeah. Aha. So we'll be able to do this def.send or .send run terminal logger. I mean, we are using this send anyways, so pre-allocate issue buffers. Oh, come on. So yes. First of all, I need to generate the code so that we have these enabled. Okay. Need to I think it did update it. I'm going to find, what do we call him? T1. Fuck. Yeah, CS pin. Okay, here's here. All right. Fine. Modules Hall SPI. Yeah, SPI through Missile. Yeah. They put it onto the 15. Default high. No, I will have to check for that. Which one is that? CS is GPIO output. Where the fuck is it? GPIO. Oh yeah. This is PB15. Low. High. Okay. As yes, it's an output. Okay. I think this is it. Fine. Control S. This is good. Hi. Generate code. We'll probably need to change more things. MAX H and C. Pragma. What is this? Hall H. Aha. User code begins 0 region. Aha. That works. User code begins 0. Where the fuck are you? Include main H. Studio. I think we have this. STDint H. STDint H. We have that. Yes. Include. Fuck off. This. All right. Put out more ones. Maybe we shouldn't do this. Whatever. So going to redo this. Going to put this into the code that begin private variables. Maybe we should put it here. Maybe we'll have to check if it works or not. I don't know. User code begins 0. Yeah. Okay. Alright. We have this. And we have this. Include MAX. Okay. Maybe should put it. Yeah, probably not here. Neither these. I don't know what this is. Unresolved inclusion. Let's see if it builds, but I highly doubt it. Yes, we should not put this here. STP handle type def. What the fuck is this? Pragma once. What is this? And this should come here like that. Yes. include this here. We take these as well, delete these. No, I think it will not recognize this shit. What the fuck is this pragma once? What is this? Unresolved inclusion? Probably because it doesn't recognize this fucking... Can we use this instead of this? No, not this one. And still nothing. I guess that was correct. Redo it. Okay. Okay, fine. Maybe we should create this. Yeah. Ordinary or globals. These, I suppose. Why the fuck does... I don't know. What if I put this here? Just curious. I bet this is not going to work here because still unresolved inclusion. I don't know why it does this shit. Still 2 errors. These 2 fuckers. Yeah, so this extend STM handle def push, it is working. I suppose this is the problem here still. Okay. Whatever, going to add these things and I'm going to debug the whole thing. MX SPI init. SPI init. What is the fuck? No mode. What up? Well, not this one. We have this PB13. It's actually not here. PB13 and 14. Because they are not GPIOs, but either sys, I doubt it, but yeah. RCC, no, these are NVIC GPIO settings 14. Yeah, these are not here. Not even here. It's going to be here, but it is not GPIO. Because it's for only 15. Yeah. Single map. They are here. GPIO. Oh, what is this? GPIO output level. Maximum. No pull up, no pull down. Push, pull. Are they orange? GPIO output level. Aha. No pull up and no pull down. Why don't we have this? Oh, I think because we need to enable this SPI bullshit. I think it should be in either no, it should be here. Should be somewhere wrong. Nope. Nope. No. RCC. No. Not NVIC. Not even ADC. What the fuck should I enable? Here I think. What is this? SPI 2? Yes. That's why. Fuck. No, which one of these? Which one of these? Okay, at least we now know that we need to do the SPI2 and oh, both of them are SPI2. Okay, great. So SPI2, SPI2, full duplex. Okay. Fuck. Whatever, so going to do this before we jump. It's not this one, is it? It's this. Nope. Why? There is a space. Okay. Okay, mapping tick. Ramp updated. Hold to run on blue button. Okay, periodic VDD update. Pressure processing. I think I will put it before this. Yeah, we'll put this before this. Alright. Okay. Lost MS. Lost TCMS. Okay. We have at the end print F this bullshit. P-core, whatever, field, P print. Is this just the print? Yes, just the printf. Okay, so. All right. Sure, there's going to be like 1,000 fucking errors. How many? How much? Only this? Interesting. Okay. Handle RUART command for quick TC bugging. Okay. Where the fuck are you? Here. STP MOX Stats. STP pause. STP go to. Where the fuck is this? Up. Dir. This is just the STP. STPN. maybe I should put it pause. Yes, should put this here. It should work. Should work. Alright. Still error on the beginning. No problem. Okay. While loop. Yes, this is added. We should put this after MX in it, but I can't because that it is not enabled. Yes, and so yes. Okay, I'm going to Control C, Control something it. Going to save this as alternative 18. Yes. Put this in here, boom, put it on here. Oh, fuck off. All right. So the current question of mine is that in the MAX, the PB 13, 14 and 15, that's what I used. PB 13 is T1 HCK, 14 is the T1 MISO or MISO, and the PB 15 is T1 CS. The CS is determined as output, always high, and the PB 14 and 13 are not enabled in the SPI2. What setting should I set it to, because it is currently disabled, but there's a ton of settings like full duplex master, full duplex slave, half duplex master, half duplex slave, receive only master, receive only slave, transmit only master, transmit only slave. What should I set the SPI2 mode? And here is the current thing. I was lazy and I didn't create a new main H or whatever, or the MAX6675H, whatever you call it. You said I can put it into the private code begin 0 section or whatever they call it. What is this pragma once as well? So I have currently 2 errors. So fatal error MAX6675.h, no such file or directory, and the pragma once in main file has this orange triangle with the exclamation mark. So yeah. Receive only master, alright. Receive only master. Oh, it has prescaler as well, 8 bits. I need to check. M is read only, you only clock data out on MISO. Mode receiver master only. NSS software because you control CS. Yes, NSS. What is that? Software, okay. Data size 8-bit, first bit MSB. 8-bit MSB first, okay, that's fine. Prescaler baud, 1 edge, all this fucking. CPOL CPHA. Start with mode 0. CPOL CPHA mode 0. Fuck. 1 edge. What is mode 0? Oh, CPOL low, CPH first edge. Yeah. Okay. try mode 1, CPH in second edge, common in mode 0, but some breakouts were better with mode 1. Okay. Your pins PB13 SCK14 should then become enabled under SPI2, and MX will generate init SPI handler HSP2. Okay. Generate code, and now noise and enabled, they are all green. Great. Good to know. Good to know. Okay. Current pin choices, okay. Default high inactive, okay. Yes, won't exist. I have noticed. Yeah. Yeah. Also, with only one, you don't need a PB15 to be SPICS. SPICS, keep it as a plain GPIO. PB15 is GPIO output. Doesn't have to be hardware NSS. Oh, is there any? XD, no. SD, Refin, Moshi, CS2. These are timers. Input, analog, even out, GPIO XD. No, this is just a simple GPIO. Oh, fuck off. Alright. GPIO output, okay. Create 2 new files in your project. Aha. How the fuck do you do that? Here it is, drivers, core. Can we, oh hello. Can we do a new header file? I think this is the .h. I'm not sure where should we put it. Here, I suppose. Start up, this is S, inc, this is H. So it seems that the H's are in the inc and the C's are in here. Alright. Okay. Core inc, oh yes, core inc MAX6675. Alright, understood. MAX inc new, I think this, because this is the H, hardware header file. Yes, we should name it this, put the thing after it. Discouraged. Yes. Now it works. Hooray! Okay. Alright, and the other one. Oh, I see what the problem is. Okay, so we put this here. Alright. Pragma once. Indef inc. Where the fuck should we put this? And if. I suppose we should put the code here. Though I'm not totally certain. Please work. Oh, this is the problem, not this. This works, okay. Alright. We should put this here. New project. C source file. Okay. Mox. Finish. Nothing in here. Alright, great. Boom, boom, boom. Oh, what the fuck am I doing? Okay, delete. Or maybe not. Yes, this is it. Max H. Yes. All okay, should be done. Alright. Alright. I don't know what I build failed. Oh, build. That's what I did. Okay, build. Building. Alright, 5 errors. Main C is not working. Okay. I should delete this to the. Then in main C you keep this. Yes, I suppose these don't need to be here because I have already done them. Paragma could be also deleted. And we should find these. Build. Hopefully it works. Great. Here we have some errors. Doesn't matter. Alright. All okay. Boom, boom, boom. Goodbye. I think this will work. Great. Great, great, great. Good. No. Static TC2. I think I should disable this, as well as like put the other thing in. One more critical. Yes, in step you have blah 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 blah, but you never call SPI MX init in main because isn't initialized in chairs. Yes, handle not extern. Init sequence becomes init. Here it is. So MX GPIO init. Yes, UART init. Team 3 init. ADC1, Team 2, SPI2. MX SPI2 init. Great, lovely. CS pin and SPI disabled confusion. Receive master only. Okay. User code begin to. User code begin to. Infinite loop. Oh, here it is. T2 for now. I don't know how to T. Oh fuck. This one was shit. But it is now alright. I'm going to call it 19. I'm going to put it in. Okay. If def guard, okay, in the H. Prog once, goodbye. Okay. Sure, okay. Okay. Row and if in, okay, fine. Measure remove the duplicate, extend his CS. What is this? Delete this line, extend SPI. Where are you? Where the fuck is it? I can't see. Hello? I just see. Huh? The main C, okay, not in this. Okay. SPI, handle def, HISP to user code begin PV. Okay, delete this shit. Okay. Okay. You have one sensor. Okay. PV should be. I will not remove this. Just pair them out, or like dash, whatever they call it. So T2C, OK. Where are you? Yes, T1C. Okay. So this will be easier to done later on. T2, T1C, T1C. Okay. Okay. Update TC command to print only one.
Mit csinálsz?
All right. Okay. No, fuck off. Delete section. All right. 2F. Boom, boom, boom. This should be it, isn't it? Whatever it asks if going to create the whole thing, going to... Oh, fuck. Mindjárt megyek. This looks worse than this, actually. What is 3? Oh, fuck. TC up. So up, TC3, TC1, okay, TC1, U, TC, yes, yeah, unsigned, blah, 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 return, okay, I think this will work. STP, I'm gonna add a few spaces here to see where it is. Read block. No, how get it? No, how get it? Homing, mopping tick, low push button, and here we have this thing for hats. Yeah, that's appropriate. Also, we should pair this out because we don't care. Yeah, we do not care about the TC2, only TC1. Yes. Really hope I don't have to. Yeah. Maybe that was the problem. Maybe that was the problem with that bullshit. Yeah, we will have to look. Yeah, we will have to look at it. So if it is not working, then it is not 3.3 but 5 volts. It needs 5 volts, but then we will have to have like a voltage divider in between, which I have, so no problem. So yeah, currently we'll need to go to I will go to eat and then come back, continue the work. I might turn off the lights for now. Yeah, I think I will. Where is it? Oh, fuck off. What is this? 1 hours. Yeah. Let's say 25. So I will AFK a bit and then come back. So I am back, or it seems. So let's go. But we have here. So we have configured everything. We have the code ready. I think I will send it to us. Control C. Put it into the txt. Put it here. Boom, boom, boom. Alright. Put it to 20. Alright. And then put 20 into here. So yeah, going to do this, and then we are going to just iterating the IDE code, then going to put it onto the I will need to find the cable. I really hope. I don't know where it is. Maybe I left it outside, we'll have to find it. I don't have that much of these long ass USB-A. This type. Oh, it's USB-B. USB. Micro. Micro B. Nope. Micro A. No. Whatever. None of this. So back to this. Alright. A few concrete problems. What are you talking about? Oh, I might have not removed it from here. Yes. Yes. I need to remove it from here as well. Did I not do this already? Seems. Oh my god, what the fuck is... What is wrong with this shit? Oh, I know. I think... Do we need this? Yes, we need this, and we need to delete this. DC, this. This. I think this will do. Alright. Yes. Remove T2C. Location mismatch. Oh. Shut the fuck up with this. This fucking shit. What is this? Main H. What is this dog shit? What? Main H. What is main H? GPIO pin 15, okay. T1 CS pin. PV doesn't matter. Yes, and that is alright. T1 CS pin, that's okay. Should work. You set, this is the basic setting, I didn't set this. Very high tens of megahertz depending on clocks. Typically doesn't need that, and long wires noise will break reads. 32 or 16. Let's go with 16. MX prescaler. Yeah, fuck. 16. Baud rate 2.6525 megabits per sec. Okay. Generate code. SPI CubeMax. I think this is it. Come on. I think this is the SPI. Yes, this is the SPI. Okay, 16 is fine. Regenerate, keep it, yes. Okay. Yes. Okay. That's done. Okay. So TC print, okay. Yes, I think this was it last time. SPI mode, power level mismatch, that might be it. Power at 3.3 and ground, remove T2, yes, done. Okay, done. Confirm T1 in CS wire choose, yes. Yes, I think this will do. We'll need to find the wire myself now. I don't think it's here. We'll need to find it. So this is a micro USB. It's not here obviously. Didn't put it in. Fuck. Need to go outside for it. Be right back. news is that I have found the wire. Bad news is that I do not have time. I have to have my dad take a car back. It sucks. But before I leave, I will upload the code to the board. Hopefully the pins are intact. Right. We are nice. And bad. Okay. I think we are okay to build. Yes, okay to build. Comply. No, hello. No, upload, whatever this is. Upload. So, yeah. Upload. Termination of previous launch did not complete successfully. Launch PMW. Launching. What is this? Download verified successfully. File server srac. I think this doing some bullshit. No. Exit. I think it's connected. Should we try to test it out? Suppose we can. One thing is that it is not on the right port. I think it is COM4 actually. It's not this one, it's this one. COM4. I mean, I suppose it looks alright. Hopefully it will run. Hello. Alright, great. We are getting data. I don't know what happened to the thing. Alright. Send. Do we have the VDDA BREF? Is this shit here somewhere? TC0. Oh, that's not good. Oh my fucking god. Yes, 5 volts. Should it be? Yeah, because if it is nothing, then the yeah. No, wiring CS wrong, SPI mode wrong, power level mismatch. We'll have to check. Wiring is, I think, is good. So I don't think that's the case because I have double checked it. So I don't think. I mean, I will now check it again. But I believe that it's not the one. I think it's the fucking voltage level is not correct. So what we are going to do is that we are going to yoink the thing out. Goodbye. So we have the white one, which is the HCK. That's the 5th pin. 1, 2, 3, 4, 5. Yes, the 5th pin from bottom up. So we have this. So 1, 2, 3, 4, 5, 14, 13, which is the HCK. HCK. Oh, no. This one. Not this one, MX. So HCK, yes. The 14, which is the next one, that is the MISO. So above that one we have the MISO, SO, which is this one. The other one is SO, this is CS. Yes, CS. Yes. CS, which is the signal. That is the last one. That is the 15th. Wow. This is plus, this is minus. Yes. There is no problem with that. The problem is, however, that we power it from 3.3 volts. That is the power problem. I'm gonna try one more thing, which is that I changed the SPI to the other setting, but I don't think that's going to do it. I might going to do the. How the fuck do we do this? 5 volts bullshit. Oh. Also check the yes, because this we have this, that CS should be connected to something, SCK to SCK and SO to MISO, and that has been done and it does not work. So the problem remains that the voltage is not appropriate, but I assume the SPI is. I'm gonna try this CPOL, CPHA, whatever this called, CPHA, other setting, but I assume the voltage mismatch is the problem. Do we need a level shifter, or could we use a voltage divider as well? That only works with analog. I have a level shifter as well, so it's not a big deal. I have even in here, so I have took it up with the board itself. I didn't realize till this point that or maybe that was the problem with the thing, is that it puts out 5 volts, and that's why I was not able to read the data with it, because from 3.3 volts we cannot do jack shit, but we cannot put the we cannot route the pin to the internal. Wait a minute, I have something. Tessék. Itt menjünk már? Jó, mindig összefoghatja. Alright, so I need to go, but I will come back. Oh, fucking hell, whatever. We're going to be here the whole day, so you will not miss anything. So get your tea ready or coffee ready or whatever, I might come back. So the problem is probably the voltage, I assume. It's not the problem. It expects. Yes. We'll do this first. But yeah, he's talking about that basically the Maxim sends out this 12-bit bullshit or 16-bit whatever. So there is like a lot of 000, all that kind of stuff that it prints out, and the board might not be able to pick it up because, but whatever, going to come back to analyze this. So going to take my little thing. Sorry. Break till, let's see, I really hope we get back here at 14 o'clock. Half an hour is nothing. I really hope 15. Fucking shit. What I need. Besides, we will have to go with this, so I will leave this here, and maybe going to put this, or maybe here. Yeah, maybe. Whatever. So yeah, I'm going to leave it here. I'm going to mute myself. So I'm back. Alright, that's work. So yeah. Mm-hmm. Mm-hmm. Um, you ain't ha Hallstatus. Mm-hmm. Float T. Mm-hmm. So we should add. What is this like? Mm. Mm-hmm. What does this do? Max read TC T0. Hall, okay. Maybe we should modify this. Because now we do read this again. T1C, where is it? T1C. It is declared, but it is not used before this. So T1C is going to be the T. Mm-hmm. Mm-hmm. Okay. Whatever, I'm going to leave it like this. Row 222 and ST equals null, you are reading zeros. Miso low, not connected, chip not outputting. Row 222, miso floating high. Row 222. SPI prescaler is definitely not 2. No. It's definitely not 2. But where the fuck is this? I don't think this is the case. I think it is, yeah, 16, so it's same bullshit. because I have to change this. Set it to 16, yes. Yeah. Ch is low. But why the fuck? Didn't we say that CS needs to be high? Then why the fuck? No, they are not. What is off 5? No, the GPIO output. Where the fuck is this? No, not here. It's supposed to be in the analog, not analog, in the connectivity. GPIO. Then if we PB, this shouldn't be. MISO only. Currently, we are configuring the PB15, which is the CS pin, to GPIO output high, and GPIO output level is high because you said so. But you also say that if the GPIO output CS is high, then the thing will not work. Basically, it will not read anything. MAX6675 only drives MISO when CS is low. So if I output CS high, or CS pin GPIO output level high, then the whole thing will not work, right? So I need to set it to low. Or do I have a misunderstanding here? Must be high when it is idle, but must go low only during the SPI read, then CS goes back to high. Still output data will break both. Okay. Nothing. Floating MISO. Okay. Okay. I wonder if this will work. Alright, then this needs to be high initially. I don't think this is the case. PB 13, 14, 15. 15 is the CS pin. Oh, yeah, I should delete this, or not delete, but like disable it. Oopsie. So I don't get it. I don't think this is the case. Okay. So save, build, then we where is the cable? Hook it back up. Into it in. Alright, we should connect to it. Hopefully we should see something. 2780, 0x2780, 0x2780. STI1, GC, Debugging, ST1. Yeah. How the fuck would you be able to do this? Hall error. Yes. Yes. It is. That's not the case. Could be, but it worked with the other thing. Thermocouple wire. Few ohms. Fucking hell. So, next thing is orange is the SO. On the multimeter, for fuck's sake. Maybe we have faulty cabling. So I'm back. Now put the thing onto full screen. Continuity. Let's check the box. Sunlight. Okay, the SCK is good. The SO is good as well. This is good as well. So we have connection. Five 5.8. 5.7 ohms. So this is good as well. I think this fucking shit doesn't get enough voltage. I only can think about that. Every wire is connecting, so it is not broken. So none of this bourgeois bullshit is applying. So I think it is just the wire, just the. Yeah, I don't think. I didn't want to short one to the other, but I have checked the thermocouple with the multimeter and it was saying 5.7 ohms, so it is, and it is connecting, so it is not broken. Yeah, I didn't didn't disconnect it. Fuck. And I will disconnect it. First I will wash my hands and then do the rest of the work. Dirty as shit. Wash my hand. Now getting some water for myself. So yeah, needing to disconnect the pin. So I think this might take longer than I expected it to. connect these. Says that this might not be tight enough. Fucking bullshit. On the square. Yeah, 5.6. 5.5. So 5.5 ohms. So I didn't do the shorting, but I have done the multimeter test, and it was every wire was connecting to the appropriate pin on the board, and also the thermocouple was reading appropriately, so it was measuring 5.7 ohms between the two thermocouple leads, and or 5.7 one connected to the MAX terminals, and when I took it off and I just measured it back one wire to the other, it was 5.5 ohms. So yeah, I don't think the thermocouple is the problem. I think it is just that the board is not meant for 3.3 volt operation. It's supposed to be ran from 5 volts, and that is why it isn't outputting any meaningful data. So yeah, I suppose that's the case, as well as yeah, I think that's the case. And so if that is the case, then we should put the make like a voltage divider, right? So that we basically divide the voltage of the CS and MISO, if I am correct. But yeah, I might be wrong. I think we should use like a 10 to 15, so a 10 kilo ohm and a 15 kilo ohm thing, meaning resistor. I think that this is the case. So 15 divided by 25, that's 0.6. And 0.6 times 5, that's 3 volts. If we change the other one, if we put it the 10 to the top and we divide it by 25, it's 0.4. So we create not 3 but 2. Yeah. And probably the but that's the MAX. Yes, but if you put 3.3 volts onto it and it has a voltage divider in it, then you will not get because I think this I have experienced this problem before with the 3.3 volts. That's not the case. I think that's still that's fucking bullshit as well. No, I don't think so. No. Level shift MISO to 3.3 volts. No. Oh, so MISO is the reading pin. Okay. Shifting only MISO. Oh. Top 10, 15, bottom gives. What's wrong? That is okay. Ten top, 20 bottom. No, we'll use this on 22. Yeah, that's too much. So SO, MISO, R top. Simple divider on MISO is more reliable. I will not it has worked with the other fucking pins, so I do not believe this is the case. I think the voltage is the problem, because I think I have run it this bitch with 5 volts and it was working pretty well. I think it's the fucking 3.3 volts that is the problem. So yeah, I'm going to use this. I think the top is the positive, so that we put to the lower. So 20, the 10k top, 20k bottom, which we will not use, and we will use the 10 and 15k. I will make a quick voltage divider. I will find my resistors. Hopefully they are here. I have a strong feeling that they are not. I said these are the lower resistors. It's not here. Yeah. As expected. Is it here? Yeah, we'll have to see. Let's see. What do we have? Let's see. We have a resistors on. Nothing. 100k. That's too much. Nope. 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 Nothing. Screws. Nothing. Right. I think there was nothing in this either. We'll put this back here. Actually, this is the level sensor chip. Little piece of shit. Yeah. Put this back in here. Yeah, fine. So we don't have anything in these. Great, good to know. We don't have anything in this either that is useful. So it's somewhere along here. I would say it's either in this. Nope. Not. So it's in this. Okay, fine. So let's find him. Let's find Nemo. So we need a not 100R. Not this. Not this. Nothing in this. Great. Nothing in this either. Caps, diodes, 10k, good. Nope, 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 nope. Still more caps, Oh, this is the bag button. Screw thingy. Is this the size of this? Maybe not. Yeah, maybe not. Whatever. So no, not that one. AD converter, these are resistors as well, not that one. Screw. Some diodes. 4.470. 15k. That's what we need. But I think we had more of this. 4.7, 3.3, 6.8, 2.2, 20k. Bought a lot of resistors for this fucking reason. 10k, we have 10k here as well. But I think this is 20k, no, 2.2k, 6.8k, 3.3k, 4.7, 10k, 1%, 15k. As well as we have here 10k, I don't know what this is. Payload resistor. Yes, there is a lot of 10k's here. This is 0.6, 0.6. This is the same thing. Yeah, this is the same thing. Good. Okay, we have this. I think I have used up the 15k things. These are basically empty. So put these back. Stacking the resistors are here. Caps, these are the resistors. Fuck off. Yeah. Other stuff. Resistors. Big ass fucking resistors. 470. These straight pins. Screws. Resistors. Caps. Resistors. No, this is diode. Caps. Caps. Pins. Caps. 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 What is this? 100R. We are not interested in the 100R. Okay. Mi van? Hát ez kurva jó. I can't have fucking 15 minutes of fucking peace. I can't have 15 minutes of fucking peace. I'm going to wake up at fucking 4. I'm getting fucking pissed off. Can't do jack shit because I need to run to here, go to there, fuck myself in the middle, do 4 things at the same time. I need these 2 things. Need one of these 15k, one of the 10k fuckers. I need to, I don't know, where the fuck do I put this? So what do we need? We need a ground cable, we need a power cable. Yes. But I am afraid that this wire is not long enough so that the bridge is there. Oh, for fuck's sake, man. Oh, come on. I will take apart this shit. Yeah, because it is on the wrong fucking place. Put it here. But that's not good either. That's not good either. Because I would need the power to be 5 watts. How the fuck do we do this? So we would need a 5 watts cable, right? We would need a 5 watts. This isn't 5 watts, this is 3.3 watts. We would need the 5 watts to be to this shit, and from this garbage we would need to put the MIA pin into this. Then connect the MISO to. Maybe I could take this off because this is already grounded. I think the 5 watts. Yes, this is 5 watts. So technically, if I remove this pin, doesn't really want to, which is a good thing at least. Have to give it that. So this is the thing of this. Fine. works. So we put this is ground, we put the signal here, and then we I suppose I don't give a fuck about that. We put the signal there, and we should find the S or MISO pin, which is the off-white shit, and we should remove it from here. And put this here. Okay. Alright. What happens if we just put the power in? I mean, nothing, I suppose. So we should remove this from here as well. Okay. We should remove the purple as well, because the purple is not good for anything. Besides, it's not good for anything. Waste. How long can the purple extend to? 5 volts. We'll remove this. Remove this. Move these pins here. So this is the VCC. VCC, this is GND. VCC, GND, and then VCC, GND, CS. The CS is going to be yellow, maybe. So this is going to be the MISO pin. The MISO, SO, MISO, OS. Alright, we should put into the yeah, so we have this here that is appropriate. So we took this, we divided it. Yeah, the ground is ground. This is ground as well. So I have one, two, three, okay. 1, 2, 3, this ground. Have to see, but I think this will work. Let's see. So we should see that the VS or this yellow bitch is connected to the ground. Alright, there is connection. Please we confirm that. Alright, so everything is on. This should beep. Alright, this should not beep. This doesn't beep. Alright, this beeps. Nope. This beeps. That should be nope. I can't really tell. But this is not it. This is the 3.3 volts. Alright. 5 volts comes here. This signal comes to here. Good. Yellow comes to here, which I can't really tell, but here I technically can. Well, I think I know why, because this is set to 200, we should set it to 12, to 12k, 20k I mean, yeah, 10,000, 9,097, so 9.97k, right, yeah, I think it was good. So orange should come to the middle pin, which is this one. Fuck off. Yeah, this is the middle one. Okay. Suppose it will good. It will be good, I think. 5 volts posit. The divider works. Yeah. I think this will work now. I mean, I really hope so. Yeah, I hope so. This is connected correctly, okay. This is connected correctly. Ground is ground. Okay, let's see. Let's see this, shall we? But I'm 70% sure that this was the problem. Oh no, let's see. Let's see this. Where's this? Okay. Where is the temperature? What the fuck is this? $8D row ST1. ST1. Yeah. Stop, this book was so no, not this is not the problem. What a fucking okay. What a bitch ass. Volts. It's still shit. We might need to fucking level shift all the suppose. I don't know why the fuck does it do that. Let's see. Let's see. Let's see with the second edge if it works. Connecting one fucking thermocouple is this fucking hard again. I want to read a fucking thermocouple. Why is this so fucking hard? Okay. Short circuit them. And we have like a little, I don't know, something that we could use actually. Like a wire or something. Is this? It's damaged, I'd say. Let's make it. Hopefully we do not fuck the whole board. Oh, that would be the best thing ever if we fuck the whole thing because of this. should do the work. I want to ask another source. So, I mean, I can talk. MAX6675. Like to use it for with a Nucleo F44R6E driver, and I have set the whole thing up, but I get garbage reading. I am overing the I have powered the board from 3.3 volts, but was not working. Also now from 5 volts, and used a voltage divider to reduce the meso pin out to the board. How would you set the MX and the settings so that it would work? Can we go from ground up? I'm fucking annoyed with this shit. This will take more than I expected to. FT 5 volt tolerant. So it says if it is FT, then it tolerates 5 volt. I don't know if this says so. No, not at all. And then this is not the best side. The ST has this garbage ass fucking garbage ass side, so you cannot fucking find it. Thank you very much for nothing. Download datasheet. Really hope you give me a fucking. Oh, it was there. 446C. Oh, hello. Power supply internally set boot modes. XT external interrupt event controller and weak. Quad SPI. Flash. Voltage regulator. I do not care about the timers. Alright. Pin out and description. Great. 144. Top view, don't care. 5 volt FTF, 5 volt tolerant IO. FT, so D7, D6, A9, C8. What is this? Pin number. What the fuck is this? Oh, the type of board, which pin we have. These are not. Hello? Oh, because these are not there. Okay, I see. Call them. Which one do I have? Oh, I don't know. This is a LQFP64. Okay, the 64 version. So this. It's called D16 PA2 PC pin name function after reset. Okay. PC PA. I mean, there is a significant amount of pins that are 5 volt tolerant, which is very interesting. PB0, PB1 as well. Interesting. FTF. What does the FTF differ from only FT? Let me check again. Where the fuck is it? Oh, here. FT 5 volt tolerant IO. Oh, so it has other options as well. Okay, so the FT is just basic 5 volt tolerant. TTA is not what you want. TTA is only 3.3 volts. Okay. FT. Yeah, a lot of FT. Basically, almost all of them are. That's cool. DG, this PC, PB. I mean, I wanna. If I find the fucking pin, PB, PD, PB 14, 15. They are. I mean, they are FT. So PB. I think this is the PB, right? Yes, PB 13, 14, 15. They are all 5 volt tolerant. Timer 8, Mizo, Moshi. This is the Mizo, yes. This is the SCK, and they are all 5 volt tolerant, so it's not the problem. So yeah. Again, they are. Mode master, receive only master. receive only master. Yes, it is, I think. We'll see. Receive only master. Hardware NSS signal. Oh. So alright, so maybe this is even too much. Maybe it's just too quick. That's the problem. '13 is the SCK, then it is the MISO, and the last one is the CS. What about hardware analysis? Low one edge. Low one edge. C4. C4 and one edge for CPHAS. I think it is called this. Yes. Generate code. Let's see if this works. I mean, we can use the voltage divider. Maybe I will disable it. still garbage, still dog shit. T, yes. Oh, I didn't upload the new file. Okay, that's why. No wonder it isn't working then. Okay, so we'll put the what do we call this? The weather. Yeah, I probably shouldn't have closed that. We'll close these. Don't care about these. Yeah, this will stay. This can stay. This doesn't stay. Where are we? Here. Build. Upload. Waiting for the debugger connection. This STM32 is always slow as fuck. Yeah, with the Arduino I like that. I can basically plug and play things like very quickly. Here it is not that simple. There is a lot of bugs here and bullshit that you need to fix. I suppose, but it is better. What the fuck is this? Alright, at least now it isn't bullshit, but it is not 380. That's not good. It is now working, but I don't know what this temperature is. Alright, we'll cancel it. So at least this is better now with the settings. The fucking baud rate. Getting this 380, sometimes going up to 448. MAX6675C. Ish. What a great concept. Why is this taking so long? This is a joke, isn't it? Then fuck you. Log. I don't understand. Why the fuck does it not work? I think it doesn't, it cannot put the whole thing into it. Why the fuck does it not work then? That's a fucking joke, this is. Please. Fuck my. Very tiring. So much so far. Yeah, making this work and also making the other things work. Might not be able to fucking make this work today. This is a fucking joke, isn't it? Like. I don't fucking understand. Oh, fuck yourself. Yo! Oh, I didn't. Oh, I'm a brain dead. I didn't. You know, I didn't hook up the thing. I used the jumper. Oh. Because nothing, it wasn't a thermocouple, it was just a random ass fucking wire in between them. Let's see again. Hopefully this time it will be working rather than not working. Yeah, it is working, but still jumping all over the fucking place. $300, $500. So yes, at least it is now working. Igen, ez van használva. Igen. Remek. Let's see with this. Let's see with the other one. I'm curious about this. Edge 2, let's say, put the 2 edge in it. Then we update the code and then we put it on. If it doesn't work, then I'm going to to edge. Okay, build, control save, great. Upload it onto the board, please. Shutting down exit. Hooray. So what we do want is that we wanna see if it is working or not. Still jumping around, it's not that. Fucking hell. Alright, let's see if we try the board or not, but I believe him because I have read the documentation as well, so we will not. I can't remember which pin it was. Oh my god. Whatever, not going to connect it back. Remove the yellow wire again. Put the off white back. And can I put you back to your place, please? Without pushing the others down. Okay. Wait a minute, what the fuck? I divided the great. I divided the CS, not the miso. Very well, good job, congratulations. I really hope that the pin is still intact. I really hope that PB15 is PB14 was SO, the yellow was put to here. The orange is the SO, which goes to the 14. So that's fine. So it could have handled it, okay. So 14 is fine. Yes. CSSO. I'm just fucking tired of this. PB14 is 5 volt tolerant. 15 as well, 30 as well. So all of them are good to know. Rising and falling. Yes. I will return. I am pissed off. Currently. Take some lumber in so that I can light the fire. Non dovrà seguire. Non dovrà seguire. Oh my fucking god. My phone just died. That's sad as fuck, innit? Yeah, 7%. I suppose. That's fine. That's fine. So what we are going to do is that we are going to I don't know. Oh, here. Just wanna look at the stats. Alright. Minutes. Yeah. Four. This is 12. Say 12, 30-ish. 12, 15. 34. That's 4 hours. Yeah, that's good. But I suppose, whatever. Yeah, going to go down, get myself. I'm just fucking tired, man. Honestly, just fucking hating this whole process. Go down, make myself a tea and a Paranatur mix, and then come back up and continue this fucking shit until I figure this out how to make it work, and then we'll go on to the planetary work after that, or maybe not if it takes too long. We'll see. How is this going to work? So this is just 8 on the square. My back. Put some music on. Oh, fucking man. That's groovy. Oh. Pissed off as much as I can. Yes. Uh-huh. Mm-hmm. Where the fuck is the... We'll have to. Really curious. I would really like it if it fucking loaded. I'm just fucking battered with this. Great. What a lovely. Hall status, hall delay. I think it should be put here. Dev CS high. Fuck. So actually it might have been a timing mismatch, because I have shorted the wire and it was working, but only when, I mean, I didn't test it with the same baud rate, but I have changed it to 32 and it worked. With the what do you call this, the thermocouple on, like clamped and installed, and without it, with only the jumper, the readings are garbage still, but not as garbage as before. And for now we don't get the ST to 1 but to 0, so ST is 0 currently, and we are so basically ST equals 0, comma row equals O, so 0, X 3803, comma open equals 0, temperature is 448 or so, and it changes from 448, there is 12 here, 512 here, there is 0 here as well, 452, 448, 256, 384, 320, so all over the fucking place. So I think it might be a mismatch, as well as like I have figured out that the STM32 pins are actually 5 volt tolerant, so we do not have to fear anything, or at least the PB 14, 13 and 15 are certainly 5 volt tolerant, so that's a good thing. Yeah, might not even need the voltage regulator or voltage divider where I use it, but probably will, because the analog is not able to read it, so that's why it is there. But besides that, they are tolerant of 5 volts, so that's a good thing. So yeah. It's complete fucking. I don't know how he interpreted this. Great. Half of the fucking thing is not recognized by the. Did it not recognize what I was? It was the half. Where the fuck is the half of it? It's still not working. So it is still not working. Just the fucking voice recognizer is not picking up what I'm fucking talking about. The thing is still not working. The readings are still garbage. They are jumping from 400 to 500 to back to 0 to 300 all over the fucking place. So it is just still shit, but at least it is now the ST, so ST is not 1 but 0 actually. So we are reading something at least. I really hope that great. Great. I think it's about here. It's not here. TCDBG. TCDBG. What the fuck is this? Yeah. Yes. Print. Fuck off. Row B2, B1, B0. Paste this here. What a great experience this is. CP flip first. is this so fucking hard? I don't care about these. Spot one. This is a fucking joke, honestly. Like, this is a fucking joke. This is a fucking joke, honestly. Like, this... It feels like when I fucking started the whole thing. It's just a fucking shit show. Garbage. So much so for the fucking... just pain in the ass. It's just a fucking garbage. This is just a fucking garbage ass piece of shit. This is. Still going to be shit. Yes. Still shit. Just pull my hair out. Fucking piece of shit this is. honestly, this should not be this fucking hard. I can't believe that this board is just this pain in the fucking ass. With the Arduino, you download a simple fucking library and then you are able to use this piece of shit. And I bet that if I fucking took the Arduino here and I would connect it, it would work as a fucking charm. Just with this piece of shit, it doesn't work. So I'm eternally fucking angry at this garbage fucking piece of shit that... Yeah, sure, you can do a lot of things with it, but this is just a fucking joke that it takes like a full fucking day to figure out. Like how... And no... I wouldn't even mind if it were a fucking day and it were there were like any sign of fucking progress. I mean, there is a bit of sign of progress, to be clear, that at least now we are reading something rather than having just fucking nothing at all. But still, it's just a fucking joke that, like, just takes a fucking whole day to fucking... And it doesn't fucking work. That's the best thing about it. It's kind of working. I mean, compared to the nothing, it is kind of working. Read MISO as GPIO input. Set MISO as a GPIO input. Fine. Who the fuck? Yes. I don't understand. God. With a TI. Can't even set it out. Great. Good to know. Use any GPIO for SCK and read MISO as a GPIO input. Or this temporary function. Static inline void dlie. Okay, let's see. Call it 21. Unambiguous. Okay, CPO 0, CPH. It is not either. The guy is just. Why the fuck? Oh my god. Just. No GPIO. PB13, I think it is now. Fuck me, PB, I think 13. Of course, underscore fucking. Then what the fuck is the name? GPIO pin 13 and 14. Yes, GPIO button pin relay limit switch added to dir pin button pin T1 CS pin it1. It's here. $13 should be. Ah! Disable SPIO2. And what the fuck should I do? Okay, for the test we should put it to GPIO. And what? Input. T1 fucking SCK. CK I say. For fuck's sake. Great. Open. Keep the single. Oh, here at the end. Right after the read. Doesn't matter. I mean, I have disabled the fucking thing, so... This is pain in the ass. Just pure suffering. Honestly. Okay. I suppose it will not even comply. It will have error. And 3, 2, 1. Alright, here we go. Because we do not and cannot why the fuck do you say that I can disable it, you fucking retard? Why do you say that I can disable it, you idiot fuck? Oh my god. Receive only master. Why the fuck do you... Oh, fucking idiot. I mean, I am the fucking idiot. I should know what I'm doing. This is just AIDS. Fucking hell. Three hours only. Great. 1730. But why the fuck do you say that I need to disable it, you idiot? Or to keep... Why the fuck do you give me this shit then? You said this to your... Just fuck me, honestly. Just fuck me. Why do you give me this fucking shit then? Why? Like, saying A, then saying B. Like shoot me in the fucking nuts. Like, honestly, like, fuck me. What is this? Like, what the fuck is this? This is a fucking joke, honestly. This is a fucking piece of shit. Stop this. I'm just... I can't take this anymore. I'm just so fucking pissed off. I wanna shoot myself in the fucking head. Why is this? Prime experience of AI usage. Prime experience. Figuring out, let's use bitbag. Then in the next section, this isn't working. So disable SPI and change the SPI pins to GPIO. Yes, yeah, in the third, yeah, actually, you didn't turn GPIO, you don't want GPIO pins. Why did you, this will not work because you disabled the SPI. Why the fuck do you say it then, you idiot? What a great fucking experience this is. Is there a fucking Is there a fucking YouTube tutorial on this fucking shit? Don't care with the fucking interface. Fuck you with the Arduino. I'm just honestly like,
because thermocouples are so common, silicon making you. Oh my god. If you're trying to measure temperature using electronics, you have a few different options, and the less expensive ones, the ones that are going to be the most accessible to somebody who's either just getting into this or as a hobby, are going to be things like thermocouples, thermistors, and RTDs. Now, if you read the title of the video, then you already know that I'm going to talk about thermocouples because that's what I'm going to use in the SMD reflow oven. But it actually makes sense for us to explore the other options and figure out why it is that I decided to use the thermocouple over other options. The other two devices that I mentioned, thermistors and RTDs, are both resistive devices. It turns out that their resistance, the resistance of the device itself, actually changes in response to temperature changes. RTDs are usually made out of really specific materials, typically platinum, and those materials have a very linear response in resistance with respect to temperature. If you looked at a graph of the temperature relative to the resistance of an RTD, you would see a nice straight line, which means that we get a very predictable result out of an RTD. It makes it really easy to measure temperature accurately. On the other hand, thermistors tend to be made out of far less expensive material, and so they cost a lot less than RTDs, typically. But the price you pay for that is that the materials that they're made out of are often a little less linear than the things that you would find in an RTD. But you'll notice that I'm saying that we have to be measuring things that are usually under about 100 degrees Celsius, and if you know about soldering, you know that solder typically has to get up to about 250 to 260 degrees Celsius, and so we can't really use those devices to measure the temperature of our SMD reflow oven. And so enter the mighty thermocouple. Unlike our resistive devices, a thermocouple can often measure temperatures up into the 1,000 degrees Celsius range. And that means that this is a perfect candidate to measure the temperature inside our SMD reflow oven, since 250 degrees Celsius is well below the ceiling for something like this. But now this works differently than the devices that we talked about before. If you take a look at this one, and now they come packaged in all sort of different things. Sometimes they'll have a big probe on the end, and a bunch of other nonsense, but this one in particular just looks like two pieces of wire that come up and then they're welded together at the tip. Kind of no big deal. This just looks like a piece of wire. But now that weld in the middle is the important part here, because the two wires that have been welded together at this tip right here are made of two completely different materials, and that, it turns out, is how this thing works. There is a very nifty physical effect called the Seebeck effect. It tells us that if we have two different materials, where they connect, if we were to apply a temperature difference between this point at the weld and this point down here where the wires are exposed again, we will get a potential difference between these 2 points on the other end of the wire. The difficulty is that the amount of potential difference, the amount of voltage that we get over these two ends of wire over here
It's
is
very
very,
little.
very small. In fact, if you measure it with a multimeter, you will see that is down in the microvolts range. But now this is a big deal because if we want to amplify the signal, and of course we will, that means that our amplifier is going to have nearly no offset voltage at all, and very, very low offset voltage amplifiers are very, very expensive. On top of that, any sort of noise that's involved because of the board or the construction or all sorts of other things comes into play, which makes these very kind of picky little devices. It also means that they can't be quite as accurate as the RTDs that we were talking about earlier. But since they are pretty much the only device in our price range that can measure the type of temperatures that we're looking at, we're pretty limited to this. But luckily we don't have to worry too much about the actual amplification of this thing. Because thermocouples are so common, semiconductor companies actually make ICs that have only one purpose, and that is to amplify and clean and communicate the temperature measured across, or the voltage measured across, this thermocouple. And that is exactly what we're going to use in this project. Maxim makes a product that I've already forgotten the name of. We're going to be using the MAX6675, and that's the K model. And you'll see that they call that a cold junction compensated thermocouple to digital converter. Just kind of a mouthful, but it should make sense to you already. We obviously want to get the ways we can do that is have a chip that actually communicates it into a digital signal, so that we actually just will get some value out of this chip, and that value will represent the voltage difference, the potential difference across the thermocouple, which will then translate into a temperature thanks to the data sheet. And now this device is an SPI device, which is great because in a previous video we set up SPI devices, saw how they work, and so it should be no big deal for us to hook up and read the temperature off of this guy. There are a handful of other options for this. Some of them use different buses. There's a very popular one that uses like a one-wire bus. If you're comfortable, obviously. You can try something like that. There's also versions of this technology that output an analog signal, which make them pretty much amplifiers, and then you can just read that analog signal with your own ADC, maybe one of the ones that's present on your microcontroller, and then use that to get the temperature. You get the idea. Now, the reason that I specified that this is the K model is that it turns out there are many different types of thermocouple. The K type of thermocouple is actually probably the most common one that you see because it's relatively inexpensive and has a pretty nice temperature range. You do tend to see maybe the J and M ones out there from time to time. I've even seen some E's, but they're actually something like a dozen or more really commonly used ones. So if you're going to use something like this, make sure that you take note of the actual thermocouple that you buy, because when you get your thermocouple IC, it better match that type. So alright, that's kind of everything we need to know to hook this up. So it's easy enough, and then we'll do it again with the STM32, which is what we're using in our SMD reflow oven, which is actually just as easy, but YouTube gets me more hits if I use the word Arduino somewhere in here. So here we go. Now, as far as I'm aware, pretty much all of the thermocouple ICs, especially thermocouple to digital, run on 3.3 volt power lines. So an actual Arduino, a normal Arduino, works on a 5 volt power rail. You can't just hook those two things up on the same power rails because you're going to explode your thermocouple IC. So just make sure that you're aware of this and hook the thermocouple IC up.
Waste of time.
it's from the IC. We're
This is a different thing. Can't use this. Oh. I will take a break. I'm just dying inside. This is a fucking joke, honestly. I'm just heaps of pissed off. I can't tell how fucking much I'm annoyed by this garbage shit. Odaadtam a lények az egyiket. Alright, so I'll take a shower break. Hopefully I will cool my head off, then I will swap to some different topic. I'm just burned out of this fucking shit. I am just very fucking pissed off, honestly. There are no words for this. So I am back, and I'm just pissed off as fuck. Yeah, I will end this stream. Eat, and then after that come back and do the planetary work. So yeah, this is it for now. Just pain, just fucking pain. I need to continue this tomorrow. Hopefully I will be able to figure it out tomorrow. Fucking hell. I do not know how long these are. I would probably be able to get away if I put the board to here, put the thermocouple here, or yeah, the thermo board relay stays here. We put the PCB here, put the board controller boards on them. They will probably take up not that much space, and then also put the, what do we have? Do we have these two, and yeah, this third fucker, the motor controller shit here as well. So I think we have plenty of space for all three of them in one board or on one board. So I think that's easy, or sort of easy, and that would require a lot less wires, meaning that it would free up a lot of space here, as well as it would not be as this fucking disgusting. Get us a lot of free wires back. So yeah, this is for finalization. Today we have been able to set the pins up and then reset them, and then been fucking around with this dumbass thermocouple for probably like more than 3 hours now, probably like 4 hours in total. I'd say three-ish hours, probably a bit more with this debugging, but still no fucking effort, still I mean, there were progress compared to the nothing. Compared to that, yes, we have values, but unfortunately still not the right ones. So we'll need to figure out what the fuck we should do and how we should be able to get these. We'll test it with the Arduino tomorrow, but I think that the Arduino just will work with it perfectly fine, and believe me. And hopefully it will, and then this is just, it is faulty, not this is buggy or something. If then that's the case, then we will figure out how to do this shit. If not tomorrow, then after that. We will figure it out eventually. It just takes time, more than I imagined, and more than I thought it would. But that's a poor expectation. Not that reality is bad. It's just a bitch, honestly. But whatever. Yeah. Alright. That's it then for you. Thank you for watching this back. Do the hard work, especially when you don't feel like it.